Hi students, welcome to Vishrut Academy YouTube channel. Today I am going to start CET on relations and functions of PUC first year and second year. In previous year, in 2015, 5 question was came. In 2016, 3 questions. In 2017, 4 question. In 2018, 3 question. In 2019, 4 question. In 2020, 4 question. In 2021, 5 question. In 2022, 5 question. In 2023, 5 question. On average, in this year, you can expect 4 to 5 questions. So, let's get started with this. Yes. Next, let us start with Cartesian product or cross product. It is also known as cross product. Here, if we consider any non-empty set A and B, we denote it as A cross B, or we read it as Cartesian product of A and B is equal to a order pair A comma B such that A belongs to set A and B belongs to set B. A cross B is equal to order pair A comma B such that A belongs to A and B belongs to B, where if set A has m elements and set B has n elements, then A cross B has m into n elements. If A has n elements, then A cross A has n square elements. Two order pairs are equal if and only if the corresponding first elements are equal and second elements are equal. That is, if I take any example, for example, 1 comma A, B comma 3. If this is the two order pairs, these pairs, this is nothing but order pair. Okay, when these two order pairs are equal, then we can equate these first element with first element of the another order pair, correspondingly second element with second order. So therefore that becomes A is equal to 3, B is equal to 1. Therefore A is equal to 3, B is equal to 1. By this property we can find the values. Next, if A and B are non-empty and either A or B is an infinite set, then so is A cross B. Even A cross B will be also of same property. A cross A is equal to A comma B comma C, where A, B, C belongs to A. This is known as order triplet. This is known as order pair. This is known as order triplet because 3 elements are present. Those 3 elements are taken from set A. Next, relation. Let R be a relation on two non-empty set A and B such that which is a subset of Cartesian product A cross B. So, in this order pair, in Cartesian product we will get order pairs, right? In those order pairs, first element is pre-image and second element is of image of a first element. The set of all first elements are known as domain of the relation R, and the set of all second elements are called as range of a relation R, and it is a subset of B, where B is called codomain of the relation R. The set B is called codomain of the relation R. Next, important note, total number of relations that can be defined from set A to set B is the number of possible subsets of A cross B. So, if they ask how many number of relations we can construct from the given sets, two sets having m elements and n elements. For example, let us consider two non-empty sets A and B with m elements and n elements. Then total number of relations, how many you can write? 2 raised to m into n. In 2 raised to m into n ways you can write the number of relations. Next, types of relation. First one is empty relation. A relation R in a set A is said to be empty relation if no element of A is related to any element of A. That is, there is no relation between any elements. Such relation is known as empty relation. Next, universal relation. In this, every is related to every element of A. Such relation is known as universal relation. Next, a relation R in a set A is called reflexive if A comma A belongs to R for all A belongs to A. In set A, how many elements are there na? Every element should be in the form of A comma A. Should be written in order pair with A comma A. Then we say that that set is reflexive. Next, symmetric. If A comma B belongs to R, if it is present, then only we have to check for B comma A. If it is also present, then it is symmetric. Otherwise, it is not symmetric. Next, transitive. If A comma B belongs to R and B comma C belongs to R, if these both are present, then we have to check for A comma C. Otherwise, it is transitive only. If these both are present, then we have to check for A comma C also. Next, equivalence relation. When we say that the given relation is equivalence, if it satisfies reflexive, symmetric and transitive, then we say that the given relation is equivalence relation. Next, properties of some well-known relations. On the set of all straight line in plane, parallel to relation is equivalence relation, but perpendicular to relation is only symmetric relation. If there is a example on straight line giving that they are parallel to each other, the condition, then that is equivalence relation. If they give for perpendicular relation, then only symmetric. On the set of all triangles in a plane, here also if the relation is similar to or congruent to, then the given set is equivalence relation set. Next, total number of relation possible from a set of m elements to a set of n elements is 2 raised to m into n. You have to remember this, which is important. Next, number of relations from A to A. If A has n elements, this is also I already said you. Again I am recalling it, 2 raised to n square. Next, number of reflexive relations possible in a set A which has n elements is 2 raised to n square minus n. 2 raised to n square minus n. Next, number of symmetric relation possible in set A which has n elements is 2 raised to n square plus n divided by 2. That's all for this session. Next, in part 2, I am going to discuss functions and also previous year questions and solve some problems related to this CET questions. Please like, share and subscribe to my channel and also support. Yes, students, in previous class I was given you do it for yourself work. So let us discuss now which all are the correct option for that. First question was let A is equal to y such that y belongs to n, y cube minus 27 is equal to 0, then which of the following is true? And the options are A, 9 belongs to A, minus 3 belongs to A, minus 9 belongs to A, 3 belongs to A. So we have to check which option is correct. In order to check, we should solve the given equation. What is given here? Y cube minus 27 is equal to 0. This implies y cube is equal to 27, y is equal to cube root of 27, which is nothing but 3. So your option is D. Next, second one, if A is subset of B, then which of the following is true? A intersection B is equal to null set, A intersection B is equal to A intersection B is equal to B, A union B is equal to A. See here, it is given A is subset of B, and if we are discussing about intersection, if there are two sets and there is condition of subset between them, then the smallest set will be the intersection value. The biggest set will be the union of the sets. So here A intersection B cannot be null set because already the elements of A are present in B, and A intersection B is equal to A. A intersection B is equal to A. Of course, this is the correct option because this is the smallest set. In A and B, which is smallest set? A. Therefore, after intersection we will going to get A only. And here A intersection B is equal to B. No, it is not possible. They are not given that it is equal to. A is subset or equal to, if they are given, then it may be there may be a chance of coming B. Next, A union B is equal to A. This is also not correct. So next, third one, if U is equal to universal set U is equal to X such that X belongs to natural number, X less than or equal to 10, A is equal to 1, 3, 5, 7, 9 and B is equal to 2, 4, 6, 8, 10. A union B complement is equal to what? We have to find A union B complement. So first write down A union B. A and B sets are given here. Write A union B. What you will going to get? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. This is A union B. Next, what is universal set they are given? A natural number which is less than or equal to 10. So, universal set will be U is equal to what? 1, 2, 3, so on up to 10. Okay. Next, what is A union B complement? A union B complement means you should leave these all elements and write which all are not there in this set. Okay. A union B complement means what? You should write the elements leaving this from universal set. Here also 1 to 10, here also 1 to 10. Leaving this means there is nothing left. Therefore, it is empty. So, therefore, empty set. Next, which of the following is false? In this given statements, which of the following is false? First one, A union A complement is equal to universal set. A union A complement is equal to universal set. It is true actually. Next, null complement union A is equal to null. This is wrong because null complement means leaving empty set, all elements are present in that. Union A means all, if we make union, we will going to get universal set, not null set. Next, A intersection A complement is equal to null set. This is true. Next, universal complement intersection A. Universal complement means null set. Null set intersection A, null set. Therefore, only false statement is this one. I hope you understood these problems.